What's up, Info Analytics Nation? My name is Jared Marrotte. This is my final project, in which I decided to analyze datasets on criminal activity. I'll cover a few things in this video, including why I felt criminal data would be useful about the data itself in my introduction, how I prepared the datasets for analysis, some analysis on the relationship between the variables, and then we'll go over my attempt at predictive analytics, and at last I'll reveal my findings and what I've learned throughout the project. So why did I choose this data? What can we learn from datasets on criminal activity? Well, I figured that it would be worthwhile studying how are different recorded attributes related to different types of criminal activities. Things like demographic backgrounds of either the victim or the perpetrator, the location of the crime, the time in which the crime occurred, etc. We can also think of trends in criminal activity. Which crimes are most prevalent? When do they occur? Who tends to commit them? Overall, this could lead to a potential of law enforcement to make better decisions by using data such as this on recorded incidents. So to potentially find answers to these answers, I've sought out two data sets from this large library of data sets related to crimes in Los Angeles, California. The first data set contained data on reported crimes in LA, that is, recorded data reported by police of a crime that happened. It contains about 987,000 rows of data and 28 attributes. Each row represents a different crime incident. And the second dataset contains data on the arrests made in LA, that is, recorded data made after making an arrest on a suspect. It contains about 324,000 rows and 25 attributes, where each row represents a different arrest made by law enforcement. So now we'll get into how I prepared the data. For this project, I used primarily Python programming and KNIME analysis tools. So for both datasets, I performed similar operations, and with the dataset on arrests in KNIME, I removed unnecessary columns, created a column for the date by cell splitting, removed unnecessary columns again as a result of that, changed variables to their appropriate types, removed missing values, and renamed the columns to more understandable names. I did similar cleaning in Python with the crime dataset. First, I read in the data, which was a CSV file. I selected only necessary columns. I renamed the columns to be more easily understood. There were also over 130 classified criminal activities, so I narrowed it down to the top 5. And I then removed missing values. So now we'll cover some of the exploratory analysis that I did on the two datasets. Beginning with the dataset on reported crimes, I first sampled 100 rows from the dataset and created a number of scatter plots to see if I could determine any relationships. First, as pictured here, I plotted the time the incident occurred related to the district area the time was reported in. This plot, and as well as the next few plots, all involve all the different crime types, and I had a lot of trouble determining a relationship between the attributes. And even after using jitter on the plot, using that function, the randomized column, no obvious relationship could really be identified, at least from my end. So after that, I tried to determine other relationships like that between the victim's age and the victim's sex, but had different or similar issues. I realized that it's probably hard to observe a cluster between 5 different classes, and also in my attempt between only predicting or clustering 2 possible categories of crime, I couldn't determine a relationship. I did find some insights though. For example, we can observe that a majority of the crimes in LA happened between 2 and 3 p.m., as well as a peak around 8 p.m. And if we look at the frequencies for each type of crime, we can observe different trends in the time occurrence for each one. Here's 3 of those total 5 I mentioned earlier, and then there are the other 2. Moving over to the data set on arrests in LA, the first thing I explored was the frequency of each crime arrested suspects were convicted of. We can see that the most common one was miscellaneous reports, which were those not formally classified, and the second most common charge was aggravated assault. Moving on, I looked at the age distribution of those arrested in LA and found that a majority of those arrested were around the age of 30. Next, I plotted the time aggravated assault arrests occurred, which was generally between 10 and midnight, and it's apparently least common to occur around 5 a.m. I then created another scatter plot of time and area, similar to what I did with the dataset on crime reports, but I had similar troubles finding a definite relationship. So now we'll move on to some predictive analytics, or at least my attempt at doing so, by means of a decision tree and k-means. So I only covered the arrest data in this presentation just because I found the most success with it. And I also narrowed down the number of charges descriptions to just 6, like I did with Python. So here are my clusters based on the bottom left plot, which represented the relationship between time and age. I chose only to classify between 2 types of crimes, possession of a firearm and driving under influence, since those seem to show actual clusters prior to the analysis. That is, firearm charges were made later in the day, while driving under influence arrests were made earlier in the day. The actual clusters are on the graph to the right, and the mean silhouette coefficients on the top left are close to 1, positive 1, which indicate co-clustering results. I also created a decision tree to determine which attributes had the most information gain and which ones were higher segmentations than the rest. And in using them, we could predict the charge for an arrest based on the attributes. Here's an example of the actual values compared to the predicted values. Now, to actually determine how effective the decision tree was, we can use the scorer node and see a confusion matrix along with a few summary numbers. We can see that our calculated accuracy was around 32.06% and our error being around 67.94%, so not very good. I thought to try again, only predicting 2 categories of crime, which was slightly better. But given the nature of the dataset, I still don't think it is something I can really rely on, however. So what did I conclude from this? There is a lot to consider when working on an information analytics project like this. And despite some of the successes I may have had, overall I believe I was not able to effectively make predictions based off of my analyses. I mean, within the criminal data set, for example, there were over 130 types of possible values, or the possible crimes that were reported, which is a very large pool and is harder to predict. And we must also consider the curse of dimensionality, which can also cause a lot of issues. Since working with several attributes, it is very important to narrow them down only to the most important, which I could have done a much better job of. Taking into account those 2 things, it can be difficult to determine definite relationships between attributes because of how many factors are being accounted for. Now, more generally, regarding information analytics as a whole, I've learned that working with larger data sets, while it can provide more valuable insights, require more attention and effort to mine effective information from them. And this leads into my next point that data cleaning and data preparation is very important. Cleaning makes sure that you are not working with a bunch of junk, which can only complicate the creation of effective models. And preparation also reduces the complications when done correctly. I also have begun to see the merit in learning different data analysis tools and applications. Different applications can perform different operations more easily, and some are more approachable depending on how you think and approach data analysis, and also the kind of data you're working with. Learning different ones also allows you to learn new ones more easily as you become proficient in using different kinds of interfaces. For example, I found Orange a lot easier to learn since it was very similar to Nime. But yeah, that's everything I wanted to show. Case closed, so they say. Thank you for listening.